All right, let's do a couple more examples using the Pythagorean theorem. Here we have a right triangle that's missing side length a. So we know a squared plus b squared equals c squared. And we know that we have to use 10.4 for the c because it's the hypotenuse. It's directly across from the right angle, so it's the longest side. So we don't know what a is. We do know b is 9.6, so 9.6 squared equals 10.4 squared. So 9.6 squared is 92.16. And 10.4 squared is 108.16. So now we're going to subtract those over. And when you subtract 92.16 from 108.16, you're going to get 16. And if a squared is 16, that must mean that side A is 4 meters long, because I have to take the square root of both sides to get rid of the square in my equation, and that's going to give us a side length of 4 meters. Now, for example F, we're using fractions, but that's no big deal. You could actually turn these into decimals, but we don't actually have to. So a squared plus b squared equals c squared. We're missing side length c, you can see, so we're missing the hypotenuse. So 2/5 squared plus 3/10 squared equals c squared. And so remember, when you're squaring a fraction, you square the numerator and the denominator. So it's like you're doing 2 squared and 5 squared. So this would be 4/25 plus this would be 9/100 equals c squared. And then I'm going to add these together. I have to have a common denominator. So if I multiply by 4, that will make this 16/100. And 16/100 divided by, 16/100 plus 9/100 makes 25/100. 25/100 is equal to 1/4. And when I square root both sides to get c by itself, the square root of 1 is 1. And the square root of 4 is 2. So I get 1/2 of an inch. Now again, you could probably even more easily just turn these into decimals right from the get-go. But I wanted to remind you that when you square root a fraction, you just square root the top and the bottom number. Just like when you square a fraction, you square the top and the bottom number. All right, this next one says you're playing capture the flag. You are 50 yards north and 20 yards east of your team's base. The other team's base is 80 yards north and 60 yards east of your base. How far are you from the other team's base? So what we're going to do is I'm going to count by tens here. It says you're playing capture the flag, and we know where your base is down here at the bottom. This is your base. So let's start by finding out where you are. It says you are 50 yards north. So I'm going to count by 10 here. So 10, 20, 30, 40, 50 to be right there. Actually, I shouldn't make that big because it's not quite where we're at. 50 yards north and then 20 yards east. So that's actually where you are right there. So this is you. And then it says the other team's base is 80 yards north and 60 yards east from your base. So we're already 50 yards, so 60, 70, 80 yards north and 10, 20, 30, 40, 50, 60 yards east from your base. So this is their base. And we want to know, how far are you? Well, we're not going to, obviously, if we're playing capture the flag, we're not going to walk like that, right? We're not going to take the long way. We're going to go straight for their base. So what I can do is I can create a right triangle. And because the distance between our base is the longest distance, right? Now, it's still a shorter distance than both the legs combined, because the shortest distance between the 2 points is a straight line, but it is the longest side. So we are missing the hypotenuse. So we know this is 30 yards. We know this is 40 yards. I'm just counting here because remember, I'm counting by 10. So we're going to set up the equation as 30 squared, which is a squared, plus 40 squared, which is b squared, equals c squared. Or 900 plus 1600 equals c squared. 900 and 1600 is 2500. And then we're going to square root both of these numbers, and the square root of 2500 is 50. So we are 50 yards away from the other team's base. That's what this distance right here is. We can use the Pythagorean theorem to find out the distance between 2 points. We'll actually do more with this in a later section. We'll do more with the Pythagorean theorem, finding distance between 2 points. We'll actually use what's called the distance formula, which is very similar to the Pythagorean theorem. All right, this one says that a guy wire attached 24 feet above ground level on a telephone pole provides support for the pole. Find the length of the wire when it meets the ground 10 feet from the base of the pole. So I'm going to use this picture we have and kind of fill in some missing information. So we know the guy wire is attached 20 feet above ground. So the distance here, where the guy wire is attached, is 24 feet. It says find the length of the wire, so we need to find out what the length of the wire is. Okay, find the length of the wire when it meets the ground 10 feet from the base of the pole. So it meets the ground 10 feet from the base. And so what we have here is we have a right triangle that's formed. And so we can use the dimension of the height of the pole where it meets the guy wire, and then the base on the ground, which is 10 feet, and we can find out what C is, which is the hypotenuse. Of course, this has to be the hypotenuse. It's across from the right angle. And that's the hypotenuse is going to be the length of the guy wire. So A squared, or 10 squared, plus B squared, or 24 squared, equals C squared. We don't know what C is yet, but we do know it's going to be the longest side. 100 squared, or 10 squared is 100. 24 squared is 576. And that's equal to C squared. And then when we add those two sides together, 676 equals C squared. And then we're going to square root both sides here. Square root both sides. And we get a nice answer of 26. So that would be 26, and we're measuring in feet here. So 26 feet for C. So that would be our answer. So we can use the Pythagorean theorem to find the missing sides of triangles. And that allows us to do real-life problems like this one here, where we have to find how long of a guide wire we would need if it's supposed to go 24 feet above ground and meet 10 feet from the base. So we can use Pythagorean theorem to find missing side lengths in real-life triangles like this one. And then number 14, I wanted to do a homework question from tonight's homework. It says, a tennis player asks the referee a question. The sound of the player's voice travels only 30 feet. Can the referee hear the question? So the sound of the tennis player's voice is going to travel basically from here to there. And so what we're going to do is we're going to form a right triangle from that. That's a really bad looking one. Let me try this again. There we go. That's a little bit better. And we're going to find out if the player, if the referee can hear his question. And so I need to know what the leg is of this triangle. So if he's 12 feet above the ground and the player is 5 feet tall, 12 minus 5 is 7. That's how long this distance of our triangle would be, is 7. We already know the other leg is 24, and so we're missing the hypotenuse, C, which is the distance between both of their faces, I suppose you could say. So A squared plus B squared equals C squared. We're going to figure out if this is true. 49 plus 576 equals C squared. Okay, 49 plus 576 is 625. And the square root of 625 is 25. Oops, I wrote 24. 25 feet. So it's 25 feet from his face to the other guy's face, and it says the sound of the player's voice travels 30 feet. Will the referee be able to hear him? Well, it only needs to travel 25 feet, so because it's 25 feet, the referee will hear his question just by a little bit.